welcome back. It's Professor Haywood, your stats professor. We're going to cover section 1.5 about other types of graphical displays of data. So far what we've covered in terms of graphs have been, we've done bar charts for categorical data. We've done histograms and box plots for numerical data. It should maybe go without saying that there are other types of graphs that we could encounter that may be useful for us. And so in this section we're just going to kind of quickly go through some of the different kinds of graphs that you might see. The reason we don't put as much emphasis on these is because the graphs that we need to really perform the analysis that we're going to be performing in the course are the ones that we've already covered, right? Bar graphs, histograms, box plots, those are really kind of the main ones that we need. But you could encounter things like pie charts or line charts or things like that in the real world. So it's useful to go over some of them so you know how to read them and how to handle them, and that's going to be the main focus of this section. So without further ado, let's get into it. Okay, so we're going to cover half a dozen or so different kinds of graphs that you might encounter. The first one is a pie chart, and I think we've probably all seen pie charts before. So let's just practice with this first example. It says the pie chart below represents the educational attainment of American adults in 2013. So we have our pie chart over here, and you can see that it splits this circle up into different pieces representing the percentage of individuals who belong to that particular category. In this case, we're talking about educational attainment, and we're asked what's the most common level of educational attainment as of 2013. So that would be the most common level of educational attainment would be the biggest slice of this pie, which it looks like is this pie, this piece right here, those who had earned a high school diploma, right? So we would say high school diploma. And then as a follow-up question, we're asked, what percentage of adults had attained that level of education? Well, we're told, right, that it was 30%, right? Right, 30% of them had attained a high school diploma by 2013. Part B asks, what percentage of the adult population had a bachelor's degree as of 2013? And so we would look for the sector of this pie that corresponds to bachelor's degree holders, and that would be this sector right here. So 20%, right? We'd say 20%. And that's all there is to that. So pie chart's pretty straightforward, I think. Okay, so let's talk about dot plots. So a dot plot is basically like a histogram or a bar chart. We're just using dots to represent the frequency rather than bars, and that's really all the difference that there is. So in this case we have a dot plot. It says the dot plot below represents the number of chocolate chips in a sample of 40 chocolate chip cookies from Subway. So if you counted up these individual dots, there should be 40 of them. And we're asked how many cookies had 26 chocolate chips in them. So we would come over to 26, right? And we'd count up 1, 2, 3, 4, 5, 6. There were 6 cookies, right, that had 26 chocolate chips in them. Part B asks, what was the smallest number of chocolate chips found in any cookie? And, it looks like the number of chocolate chips ranges from 19 to 30. Okay, so the smallest number of chocolate chips in any given cookie was 19. There were 2 cookies that had that number of chocolate chips in them, but we would say 19 chocolate chips. And that's it for that one. So that's how dot plots work. Let's take a look at stem and leaf plots. These ones are a little bit more confusing maybe, but you may encounter them from time to time, and so let's practice reading stem and leaf plots. So a stem and leaf plot is a chart used to organize a data set from smallest to largest. The rightmost digit is the leaf, and the rest of the digits form a stem. So if you had a data value of 1.47, then the rightmost digit, 7, would be the leaf, and the remaining digits, in this case 14, would be the stem. We kind of ignore the decimal place for that. Okay. Consequently, when we are reading a stem and leaf plot, there will usually be a legend telling us that 69 line 5 means 695 and not 69.5 or 6.95 or something. We wouldn't have any way of knowing that unless we were given a little key like this. So let's practice interpreting a stem and leaf plot. Here, this stem and leaf plot represents the time between eruptions in seconds for a random sample of 45 eruptions at the Old Faithful geyser. So just to kind of get our bearings here, we have 67 and then a line and then 2. That corresponds to 672 seconds. So the 28 over here indicates two different observations. We had one eruption that occurred 672 seconds after the previous one, and then we had a separate eruption that occurred 678 seconds after the previous one. We didn't have any eruptions that occurred from 680 to 689, but we did have a bunch of eruptions that occurred. We had one that occurred 695 seconds. Actually, we had 3 eruptions that occurred 695 seconds after the previous one. We had one eruption that occurred 696 seconds after the previous one, and so forth, right? This is how we would read these. There were 2 eruptions that occurred exactly 700 seconds after the previous one. Anyway, so part A asks, what's the smallest number in the sample? Well, that would be 672, right? It also asks, what's the largest number in the sample? Well, here we would go down to the largest stem and look for the largest leaf on that stem, and that would be 738. Okay, that was the largest. Okay, part B asks, how many eruptions occurred exactly 702 seconds after the previous one, after the previous eruption? So you'd look at the stem and leaf plot and look for how many times 702 occurred. Here we have 700, another 700, here we have a 702, and then another 702. So it looks like there were 2 of those. And finally, for part C, how many eruptions occurred exactly 712 seconds after the previous one? 712, so we would look 700, and then we're looking for, a stem of 71, and then we would be looking for a leaf of 2 for 712. But I don't see any leaves that have that are 2s in this stem, so I would say 0. There were no eruptions that occurred exactly 712 seconds after the previous one. So this is how you read a stem and leaf plot. And the nice thing about a stem and leaf plot is that it's kind of a built-in histogram. Like if you tip it over on its side, then you kind of get a little histogram out of this. And so you could comment on the shape of the distribution a little bit. This one seems maybe left skewed because of these, but possibly also symmetric. It's a little bit hard to tell, but anyway, so that's the idea there. So that's stem and leaf plots. Finally, another really common graph that you might encounter are line charts. Line charts are especially good for showing how a variable changes with time. This is in statistics, this is called time series analysis. And we're not going to do any time series analysis in this course at all. But I mentioned this graph here because students will oftentimes want to use a line chart if they've collected some of their own data and it corresponds to time in some way. Then this is a chart that you would want to put together, and you might encounter this in the real world from time to time. So the idea behind a line chart, if you're trying to display some kind of time series, is that along the x-axis you would have some unit of time. In this case, it looks like we have years down here, but it could be months or it could be days or something like that. And then you would just show the way that the variable changes from year to year in this case, or from month to month if it was months along that axis. In this case, we're told the line chart shows the high school enrollment in a small town from 1984 to 2020. So the high school enrollment. So in 1989, the enrollment was maybe like 65, okay? And in 2009, the enrollment was about 100. So yeah, a pretty small town, small school. But this line chart gives the enrollment trends. Part A asks, what was the enrollment in 1996? So in 1996, it looks like the enrollment was somewhere between 80 and 100, maybe closer to 90, so maybe like 88, 89, something like that. Say about 88. Okay. Part B, when did enrollment hit its peak? In other words, when was enrollment, what year was enrollment at its highest level? That would be this point right here, right? That occurred in the year, this is going to be hard, but I think it's 2003. I went a little bit crooked there towards the end, but I think it's 2003 when it hit its peak. Okay? And then part C asks us to describe the overall enrollment trend. So I would say enrollment seemed to be rising until about 2003, and after 2003 enrollment has been falling. That's kind of the basic trend. So enrollment rose pretty steadily from 1989 to 2003, after which it fell pretty steadily. In fact, enrollments have returned almost back to the level that they were at in 1989, right? So almost back to the levels in the 90s, right? Something like that. Okay, you could kind of describe it different ways, but that's the idea. So that's it. Those are the graphs that I wanted to show you. There are others, of course. There are lots of other kinds of graphs, but that just gives you a sense for, I think, gives you a sense for some of the different kinds of graphs we can see. We can practice making some of these in Excel real quick. Most of these are pretty easy to put together. So let's head over to Excel. So this is the data set that I've given us to work with to kind of practice making some graphs here. We talked about pie charts. Okay, so we can make a pie chart. Pie charts are really good for categorical data. Day, year, budget, all of this stuff. This is all numerical. So the only categorical data we have really is month. The movie, each of these are going to be different categories. So it wouldn't make sense to make a pie chart out of the movies, but we can make a pie chart out of the month column to see maybe which month of the year is more likely to be the release date for a movie or something like that. So we could do that. In order to do that, I'm going to select all the data in the column. So I'll hold down Control, Shift, and down arrow. And notice that there are over 5,000 rows in this data set, so it's a very large data set compared to what we're used to working with. But in order to get a pie chart, unfortunately, if you just select pie chart, it's not going to make one. So what you have to do is insert a pivot table. So we'll insert pivot table in the existing worksheet. Okay, I want to count up how many movies were released in any given month. And then I should be able to make a pie chart out of this table. Let's see. If I go to insert and pie chart. Okay, so now I get a pie chart. And you can see the key over here to tell you which colors represent which months and so forth. So that's how you would put together a pie chart. Okay. It looks like this sector is the biggest one. This corresponds to December. So the month with the largest number of movie releases appears to be December, right, from this pie chart. Okay, so that's how pie charts work. We talked about dot plots. Now, Excel does not have a very good way of making dot plots, so I'm not going to bother trying to make a dot plot in Excel. It's really kind of a pain. Same thing goes for stem and leaf plots. I'm not really going to bother showing a stem and leaf plot. We can make a line chart though. So one interesting line chart would be to compare how movie budgets compare to the year of release, because you might expect that budgets have increased with time, right? Movie budgets have increased with time. Or another interesting comparison would be worldwide gross compared to year. Okay, so that's what I'll try to do. Let's see if we can get a line chart to show how budgets have changed with year. Okay, so here's how we would do a line chart if we wanted to compare year and budget. Okay, so I would hold down Shift and select both of those columns. And I'm going to have to insert another pivot table to do this. So I'll go to Insert, Pivot Table, and let's just put it right underneath this pivot table we made a second ago. Okay. So I want to put the year in rows. Okay. And then what I want to do is have the average budget, the average movie budget for each year counted up or calculated. So I'll put budget down here in the values, and I don't want the sum, I want the average. So I'll go over here and say value field settings and change this to average. So now what I can do is actually, let me make sure that I don't have any, there's a blank row, so I'll get rid of that box and say okay. But now what I can do is select this table, so I'm just clicking and dragging until I get to the end, and then insert, and I'll insert a line chart, and there you can see that our suspicions are confirmed, right? Like the average movie budget has increased with time. So that's kind of what this chart is showing us. I can make this a little wider so maybe some more of the years show up on that x-axis. But anyway, that's the idea with that. I think that's all I need to show you here. You could, of course, make histograms out of the worldwide gross or whatever else you want to do, but we've practiced doing that kind of thing in the past already. So that's how making graphs, other than the ones we've already talked about, that's how making some of these graphs works in Excel. So that will do it for this section, and I'll check in with you in the next one.